Right, time for another video, this time about the Linksys Velop mesh Wi-Fi routers. We use that in this house. We have 4 of the tri-band nodes dotted around the house, and they work really well. They're very simple to set up. You don't have to worry about them. We've positioned ours in 2 on the downstairs floor, on the ground floor, sorry, 2 on the upstairs, and we have decent Wi-Fi everywhere, so that's great. And as I say, they're very user-friendly. You don't need to do a lot. You just plug them up, set them up, plug them in, get them going, and then forget about it. However, I quite like being able to tinker with the devices in my house, be able to set them up so that they work in the way that I want them to work. And one of the biggest features I feel that is missing from the Linksys Velops is some sort of alerting when a new device connects to your network. That's not natively available within any of the menu options that I can see anyway within the Linksys Velop menu options, within the Linksys Velop configuration menus. And from what I can see on the Linksys Velop forums, this feature's been requested and it hasn't arrived yet. So what I thought of doing, I did some reading about this, and I found out that the Velops do broadcast on using Mqtt. Mqtt is a protocol used by many Internet of Things devices to communicate with each other. So to broadcast current state or to set current state. And so what I did is I wrote a very simple Python script that listens to the Mqtt announcements or alerts from the Linksys Velop routers or the mesh network, and I use that to compare against a known list of MAC addresses, and if a new MAC address appears, I fire an email. And this video is going to be me showing you the Python script I wrote to do this. It's a very, very simple Python script. I am by no means a coding expert. I have just picked up a little bit by Googling and looking on the internet. And I feel that this fills one of the gaps that I was most frustrated about with this system. So I thought I would share it, because there might be others out there who would appreciate this type of functionality with their Linksys Velop network as well. So let me share my screen. I'll walk you through my script. If anyone has any questions, please do leave them in the comments below. I can't promise I'll be able to answer them, but I can certainly try. So yeah, so if you find this video useful, please do give it a thumbs up. Please do subscribe. I'll be trying to post videos like this, and also about smart homes and Teslas and solar and all that kind of stuff fairly regularly, a couple of times a month ideally. So yeah, so let's get on to my computer. Oh, one last thing, I've got a couple of referral links below. One for Tesla, one for Octopus Energy. Check them out if you're interested in either of them. And yeah, now onto the actual script.
Okay, this is my Raspberry Pi. I use Raspberry Pis for all of my projects like this. So I write my code on these Raspberry Pis, and then I run the scripts on these Raspberry Pis as well. They're fantastic. They're such cheap little devices that are very powerful, or at least easily powerful enough for this type of query or this type of script, and you can leave them running all the time. But before we get onto the script, I first wanted to show you the 2 types of JSON response that we're going to receive from the Mqtt payload when we're listening to devices connecting to our network. And we've got 2 different types here, because there's one structure for a device that connects via Wi-Fi and a different structure for a device that connects via Ethernet. And based on the type of connection, we're going to have to pull out different fields from the JSON payload that we receive via Mqtt. So here's the first one. This first one on top is an example of an Ethernet connection. You can see we get a whole load of information. I've redacted some of this, or I've removed some of it, just because some of the information is specific to my network. But you get a unique ID, and then a time. This is very useful if you're wanting to record exactly what time the device connects. But then you get this down here. So inside the data section within the JSON, you will get both the MAC address of the access point as well as the MAC address of the actual machine that is connecting. So this is the MAC address that we'll want to pull out so that we can compare it to our known list of devices. So note that that is within data and then client MAC. Within the Wi-Fi example, it's very, very similar, but the fields that are returned are slightly different. So again, we have this data field, but inside that we do not have a client MAC. Instead, we have an AP BSSID, that's the access point MAC address, and then we have this STA underscore BSSID. That is the MAC address of the device that's connecting. So when we're writing this query, this script, the Python script, we're going to need to take into account that we could be receiving one of two types of JSON response, and we'll need to make sure that we are putting the right information out of each of the JSON responses that we receive. Okay, so now we've had two examples of the types of JSON that we'll receive via MQTT. Let's now move on to creating the script. Okay, so now that we have seen two examples of the JSONs that we will be getting back from the MQTT broker, now we can actually start to write the Python script. So basically, in this Python script, what we want to do is we want to subscribe to the MQTT broker from the Linksys Velop and listen for messages that are going to be focused on devices that are connecting and disconnecting from the network. When a message comes through, we want to pull out the MAC address of the device that's connecting, and we want to compare that MAC address against a list of MAC addresses that we've seen on the network before. If the device does not match the known list, then we want to send an email to an address, and we want to add that device to the known list so that it doesn't trigger a subsequent email. And we want to store that list of known devices in a file so that we can use it again the next time the script is launched, so that we don't start from scratch each time the script is launched. So with all that in mind, let's start writing the script. And the first thing I'm going to do is I'm going to define a file that we're going to store this list of known devices in, and then I'm going to read that file into a variable so that we can read it whenever we need to within the script. So let's start. Let's call the file known devices underscore JSON. I'm comfortable working with JSONs, so that's why I'm storing it in that format. But in theory, you could store this in a CSV file or any other flat text file. So I'm going to define the file, and I'm going to define the path for that file. So put a / home by there we go. So I've defined a path for the file. Then I am going to define a function so that we can use it at any point during the script called def known devices function. And inside that function, I'm going to open that file. In read mode. And I'm going to call that file handle. And then what I'm going to do is I'm just going to return, I'm going to decode that as a JSON and return it from the function. I'm just going to break these up. I always find it useful just to break up the code with pound signs or hashes so that it's obvious where the function starts and stop. There we go. So now we have a function. Let's now put that function, or call that function, sorry, and store the results in, oops, can't spell, into a variable. Okay, so we've defined the path to a file, and then we've defined a function that reads that reads the JSON in that file and returns it into a variable called known devices. Except, just noticed a typo already. I'm sure there are going to be lots of typos in this script. I must also mention I am not a coding expert. I'm not a programmer. As I mentioned at the very beginning of this video, I've put together this script by doing a whole load of Googling. So I'm sure that there are much, much better ways of doing this. This is just the way I have done it, and that works well for me. Okay, so now we have a variable called known devices that will store the list of devices that we know about on the network. Now, what we need to do is, in fact, first, let's just print that list. In fact, let's just run this now, because in theory, we should get whatever contents is in that file. And I've also just forgotten that you obviously need to import the modules that we've used. I think so far we've only used JSON by the look of it. Okay, so if I click on run, hopefully, I've got to save it. There we go. Excellent. So you can see here it's returned 00000. This was I've just entered that within the JSON file just as a starting point so that we've got something to compare it to. But that proves that this is reading that file and storing the contents of the file in the variable. Right, let's carry on. So the next thing we need to do is we need to actually connect to the MQTT broker. So let's import everything we need for that. So I'm using the Paho, MQTT.client. This was, I'll include a link to this in the description below, but this was the tool I found that seems to work very well for this. All right. So now let's define a broker address. The broker address is the address of your router, the primary node from your router. So for me, that is 10.217.1.1. You're probably, I think the default though is 192.168.1.1 or 192.168.0.1. But whatever your primary node is, enter the IP address there. So just put a note next to it so we remember what it is. And then we need to define the topic that we want to subscribe to, the MQTT topic. So all MQTT broadcasts, I think that's probably the right word, have a topic and a payload. The topic is something that you can subscribe to. You can either just subscribe to all topics or you can subscribe to specific topics. And if you subscribe to specific topics, you will only receive the MQTT broadcasts that are related to that topic. So to try to reduce some of the noise that we're going to receive, we're going to subscribe to the network /plus. A plus sign is a wildcard for MQTT, then plus again, then subdev, then plus, then status. I found through a bit of trial and error that this seems to be the topic that is used to announce devices as they connect and disconnect from the network. All right, so now that we've defined that, let's actually set it up. So right, let's define a client. You can, we need to give it a name. It can literally be anything you want. So I'm just going to call it Raspberry Pi Demo, but you could literally call it anything. Then now let's define what we should do when we receive a message. So client.onMessage, and then I want to call a function which I'm going to call onMessage. Now we need to connect to the broker. So client.connect, and then we need to define the broker address here. So that means connect to the IP address we defined above. Now we've connected, we need to subscribe to the MQTT topic that we want to subscribe to, which we've defined in that variable. Now that we've subscribed, we've connected and subscribed, we now need to wait until the message comes in. So what we do is we set up off a client.loop_start. This will put the script into a loop forever as it just waits for new messages. Okay, that is it. Right, so now we have read our list of known devices into a variable, and we've connected to the MQTT broker, listening to a specific topic, to this specific topic. Now we need to define what to do when a message is received. So let's create another function called def_on_message. And that function has a few variables passed through to it, which is client, user data, and message. This is all contained within the Paho MQTT manual. I'll include a link to that in the description below. Right, so we're going to want to use the known devices function, the known devices variable inside this function, and we're going to want to update that known devices variable and then use it again later, which means that we need to use a global variable. So we need to define that at the beginning. Known devices. Okay, and now what we need to do is we need to create a variable. I call it parameters or params, which will be the JSON that is received as part of the payload of the message. So all of the MQTT payloads, as you saw before, they're all in JSON format. So we're going to decode that as a JSON and store it in the parameters variable. Now we've got that, we need to work out whether it is a connect or a disconnect. So referring back to those two examples I showed before, we know that there is a field called status, and that's either connected or disconnected. So if we create an if here, that goes to the correct part of the JSON, and then we set that to equal exactly connected, then we know that this next bit of code will only run if the status is connected. It won't run if the status is disconnected. Okay, now we need to work out whether it's an Ethernet device connecting, or a device connecting via Ethernet, or a device connecting via Wi-Fi. Now the easiest way I found to do that is to search for the field that is only present in one. So let's search for the MAC address field that is used for a Wi-Fi connection. So if that is in params data, then we know that it's a Wi-Fi connection. So let's define a device MAC equals params data sta_bssid. Okay. Otherwise, we know it's a device connecting via Ethernet. So let's then set device MAC equals params data, and then that was client_MAC. Okay, so now we've defined a variable called device MAC and pulled in the correct field from the JSON depending on whether the device connected via Wi-Fi or via Ethernet. Okay. So now we need to check to see if that device is in the known devices list. So if device Mac not in, and then it was known devices, then we want to do something. So let's just first print unknown device. Oops. Connected to network. Then what do we want to do next? I guess we probably want to add the device to the known devices. So let's do that. So known devices.append device Mac. So that means we've added the known device to the end of the current known devices variable, or known devices list. Okay, so now we need to send the email. I'm going to use a function that I often use for this. So firstly, we need to define the subject. So I don't know, unknown device connected, and let's actually put the MAC address. Unknown device, like that maybe. So okay, there you go. And then let's define the text in the email. So I guess we're probably going to do the same sort of thing. Unknown device connected. In fact, let's just do that. There we go. In fact, when we do unknown device connected at, and then let's put the time in as well. So now we need to do format unknown device equals device Mac, and then time equals date time dot now, and then one final close. Okay, and then we actually need to send the email. So let's do send. So I always call the function send email, and I'm going to pass through a couple of variables. So let's do sender email. Oops. Receiver email. Subject, which I've just defined above, and text. Okay. Right, now we need to define that function, and we also have used a whole load of variables that I haven't, sorry, a whole load of modules, I think they're called, that I haven't defined yet. So we've got to import date time. If I import time, actually, I don't think I've used time. Maybe it's just date time. So it's from date time, import date time. Okay. And then we're also about to use some SMTP, lib, and SSL. Okay. Plus, I need to define some of these variables. So sender underscore email equals, let's put that as input. So that will prompt me on the command line to enter the sender email, and then receiver email equals input, enter receiver email, And then we also want sender password. So let's do the same thing, input. Okay. We're going to be, I use Gmail, so let's define a couple of things that will make that work. So email ports, Gmail uses port 465, and the SMTP server is smtp.gmail.com. Okay, so let's define another function. So def send email, and we have passed through, so let's call it eSender, eReceiver, eSubject, and eText. Okay. So let's just print sending email, just so we know when we're hitting this function. And then we need to define the body as being equal to the word from, %s, oops. Okay, oops. Percent e underscore receiver, and then subject colon %s percent e underscore subject. Okay, so this was something I found online that works very well. And then we now need to actually send the email. So context equals ssl.create default context. Okay, so this is now just establishing the connection with the email server. And then we need to actually use it. So server.login, which is e underscore sender, and then sender password. And now that we've made a connection, we need to actually send the email. So server.send mail, e underscore sender, e underscore receiver, and then we then join that body that we've defined above to be the message and the subject and everything. So, and that should be it. Right, okay, so now we are in this function down here. When we receive a message, we are confirming that it's a device connecting to the network rather than disconnecting. And then we are determining if it's connected via Wi-Fi or via Ethernet and defining this device MAC variable based on that. Then we're checking if that device MAC is already known, and if it's not, we are appending it to the known devices list, and then we're sending the email. So the very last thing we now need to do is we need to write that to update the known device's JSON file so that if the script were to exit and restart, we would be able to repopulate that known device's variable with the existing devices that we already know about. So let's find another quick function for that. And I'm just going to do that down here. So yep, that's right. So we want to do it right here. So we want to do write known devices function. And just while I'm here, let me just add this in. Okay. So we've got a read known devices. Let's now do a def write known devices. And that is going to be almost exactly the same as the read, but this time we're going to do with open known devices JSON, but we're going to open it in write mode. And then we're going to do a JSON.dump of the variable known devices into the file. Okay, so I think that's it. So we now have a short bit of Python code that will will subscribe to the MQTT broker, listen for new devices as they connect to the network, check that against the known list of devices that we already know about, and fire an email if a device we do not know about tries to connect. Now let's try and run it. I am positive I will have at least one typo somewhere in here. In fact, I can see one right there. So this is undoubtedly not going to work first time, but if it doesn't, we can work out why it's not working. So let's give it a go. Okay, so I put a colon there where I shouldn't have. Okay, let's try again. And I can't spell. Okay, so I found a small error in the script, which was just here, this line here. So originally it said json.load rather than json.load_s. The s in this signifies load a string, and the message is being received as a string, so that's why we need to use the load s. Anyway, I fixed that, it's now working. So let's try this again. So enter the sender address. Okay, so the script is now running. So let's try disconnecting and reconnecting my mobile phone. Okay, excellent. So it has recognized that a new device is connected and it's sent an email. Let's make sure that email does arrive. There we go. Excellent. So I'll put a screenshot of the email up now, but you can see it tells me that my unknown device is connected, and it gives me the MAC address, and then it tells me the exact time that device connected. Let's now disconnect and reconnect another device. So I've disconnected it, and now it's reconnecting. There we go. New device connected. There we go. They're coming in thick and fast now. So devices are now connecting to the network, and each time it does, I am getting an email to alert me that that device is connected. But most importantly, once the device is connected once, that device is then stored in that variable, so it won't fire another email when the same device reconnects. So there we have it. That's a very simple Python script that will add the new device alert functionality to the Linksys Velops. I'll include a copy of the Python script below so that you can use it if you wish. Please do give this video a thumbs up, and if you found it useful, and do subscribe for more content like this. This is a bit of a different video for me, but if people like it, I will certainly try and do more like this in the future. So yeah, thank you very much for watching, and I'll see you in the next one.